Okay, so let's say that we wanted to find the value of the angle sine theta equals 1 over root 2, and that angle is going to be between 0 and 2 pi. Okay, so we will always give you an interval over which to find it. It might not always be between 0 and 2 pi. It might be minus 2 pi to positive 2 pi. It might be pi to negative pi. So when I say from 0 to 2 pi, basically I'm asking you to find an angle that has a ratio of 1 over root 2 as we go around the quadrants once in the positive direction. Right, so starting at 0, ending at 2 pi. So the first thing that is going to help us determine that is our cast rule. You may or may not remember this from grade 11. So the cast rule helps us decide which of the ratios are positive or negative in each quadrant. So if you think of creating a triangle in quadrant 1, all the sides of that triangle would be positive, right? X is positive, Y is positive, and the hypotenuse is always positive. So that means that all ratios would be positive in quadrant 1 because sine is opposite over hypotenuse, so y over r. Cosine is x over r, and tan is y over x. So the A means all, right? All ratios are positive in quadrant 1. If I draw a triangle in quadrant 2, now the value of x is negative because it's in the negative part of the x-axis. So what ratios does that affect? Well, that affects cosine because cosine is x over r, and that's negative. And it affects tan because tan is y over x, and x is negative. The only one that stays positive is sine because sine is y over r. So that's why we have an S in quadrant 2, because that is indicating that sine is positive and the other two are negative. And then if we draw a triangle in quadrant 3, both x and y are negative and r is positive. So the only one that stays positive is tan, because x is x over r, sine is y over r, but tan is y over x, and they're both negative. So that means tan is the only ratio that remains positive in quadrant 3, and then finally in quadrant 4, x is positive, y is negative, and so the only one that stays positive is x over r, which is cosine. So that's where the cast rule comes from, is that all ratios are positive in 1, only sine in 2. So that means that the other two are negative, only tan in 3, and only cosine in 4. So the first step when you're solving these is that we look at the ratio that is given, and we're going to decide what quadrant it could be in. So that's step 1. So this one is a positive sine ratio. So I usually just do a little sketch here because I'm a visual person and I like to see what I'm doing. So I can see that sine would be positive in 1 and 2. So that's the first step. Decide what quadrants it could be in. So you're going to get 2 answers because it could be in more than one quadrant. Step B is to draw a diagram and label it. So I'm going to draw a triangle in quadrant 1 and a triangle in quadrant 2. And we have been given the opposite side of that triangle and the hypotenuse because we have sine. So the opposite is 1, the hypotenuse is root 2. Okay, so we're going to draw a triangle in both of those quadrants. So we're going to label the 2 sides that we've been given, keeping in mind that this is the angle we want to find right here. Okay, the angle between the terminal arm and the x-axis, which is the related angle. So that's step 3. Step 3 is find the related angle. What kind of triangle did we just create? Well, this is where we want to compare to our special triangles. So we have one that is pi over 4, and we have one that is pi over 3 and pi over 6. And we want to compare. So when I look at this diagram, the hypotenuse is root 2, so I know it has to be a pi over 4 triangle. So my related angle is pi over 4. That means this angle is pi over 4 and this angle is pi over 4. Okay, so determine what kind of triangle you just created. And then finally, the last step is to solve for the angle, or we might use x instead of theta. So how do I find the solution? The solution is always from 0 to the terminal arm. So in quadrant 1, if I start at 0 and go to the terminal arm, that angle is pi over 4. If I go to the terminal arm in quadrant 2 over to here, well, what is that angle? Well, that angle is not quite at pi. How far is it before pi? It's pi over 4 before pi, right? So it's not quite at pi, so I'm going to subtract the related angle to find that angle. So if I do pi minus pi over 4, that equals 3 pi over 4. So that's my second solution. Okay, so those are the 4 steps you want to follow. Used your cast rule. I don't know why I did that. Okay, use your cast rule to decide the quadrants, draw a diagram and label the 2 sides you've been given, determine the related angle, and then solve. Okay, so let's do this one. If cosine is negative root 3 over 2, determine the possible values. So step A, I'm going to use my cast rule to decide what quadrant it could be in. My cosine ratio is negative, so it could be in 2 or 3. It's not in 1 because they're all positive, and it's not in 4 because cosine is positive in 4. So it must be in 2 and 3. Step 2, I'm going to draw my diagram. So I've got a triangle in 2 and a triangle in 3. And I'm going to label the 2 sides that I've been given. So I've been given the adjacent side and the hypotenuse. The negative would be with the adjacent side because the hypotenuse is always positive, and also the x is in the negative part of the x-axis. So next step, determine my related angle. So I need to figure out on my special triangles which angle is next to or adjacent to the root 3. So I'm going to look at my special triangles that I drew here, and I can see that next to or adjacent to the root 3 is always the pi over 6. So my related angle is pi over 6. Okay, so pi over 6 is always adjacent to root 3. And then finally, I'm going to solve it. So my solution set is from 0 to the terminal arm. So in quadrant 2, we're not quite at pi. So we're going to subtract our related angle from pi to get our first solution. So it'll be 5 over 6. And then in quadrant 3, I am past pi. So in quadrant 3, I'm going to take pi plus the related angle because I'm past pi, right? I'm more than pi. So pi plus pi over 6 is 7 pi over 6. So 5 over 6 in quadrant 2, 7 over 6 in quadrant 3. Okay, let's see if we have any questions so far. Okay, let's look at another one. Okay, if tan theta equals root 3, tan theta equals root 3, find the possible values. And you'll notice the interval is still from 0 to 2 pi, so we're just going around once. So I'm going to determine what quadrant using my cast rule. So my tan ratio is positive. So tan is positive in quadrants 1 and 3. So then I'm going to draw my diagrams. So I've got a triangle in quadrant 1 and one in quadrant 3. I need an opposite over an adjacent. So root 3 would be over 1. So opposite the angle is root 3 and adjacent is 1. Then I have to determine my related angle. What kind of triangle have I created? So what's that angle here? So this angle is adjacent to the 1, right? I want to see which angle is next to the 1 and opposite the root 3. So I'll look at my special triangles here. So I can see here that next to the 1 is always root 3. So that's my adjacent angle is pi over 3. So this angle is pi over 3, and this angle is pi over 3. And then I can solve it. So my solution set is from 0 to the terminal arm in quadrant 1. Well, that would just be pi over 3. And then all the way around here, I'm past pi. So I'm pi plus pi over 3. So that would be 4 pi over 3. All right, so all the same, 4 steps, cast rule, draw the diagram, figure out the related angle, and then solve. Okay, well, what if sine theta is 0? Well, that does not match up with any of my special triangles. First of all, I don't know what quadrant to put it in because it doesn't apply to the cast rule. It's neither positive or negative. And when I look at my related angles, there's no 0 there. And my other one, there's no 0 there. So my second option, if we can't use the special triangles, we're going to look at the graph. So if you get values, so here's my sine curve. So I'm just going to sketch the sine curve from 0 to 2 pi. So sine starts at 0. So here's a sine curve going around once, right? 0 to 2 pi. So I can see from the sine curve where it hits 0. It hits 0 here, here, and here. So that is easy to determine. That's my solution set. I don't have to find a related angle because what has happened is as I go around the circle, I've landed on quadrants, right? So it's 0 here, it's 0 here, and it's 0 back to the beginning. So you can't draw a triangle and you can't figure out a related angle because there are none, so you're just going to sketch. So my solution set is that sine theta would be 0 at 0, pi, and 2 pi. So that's my second option. If I can't use the special triangles, can I go to the graph and find that? So we can use the graph for values of 0, -1, and +1. So if I get sine or cosine that equals 0, 1, or -1, I can just sketch the graph, right? Because I know it's 0, 1, 0, -1, 0, and those are easy to find on the graph. So that's my second option. Can we use the graph? Okay, so here's one for cosine. Cosine is -1. So I can't use my special triangles. I'm going to use the graph, and I'm just going to sketch the graph from -pi to 2 pi for cosine. So I know what this looks like. And it goes up to 1, down to -1, and I want to go to pi, or negative pi. So sine, or cosine we're doing, so cosine starts at the top, middle, bottom, middle, top, and then continues this way. And I want to know where it equals -1. So it equals -1 here and here. So here and here are my solution set. So cosine theta equals -1 at pi and also at negative pi. So just check and make sure that you're finding the answer over the proper interval. Sometimes the interval changes, so just always check it and make sure that you're finding it over the proper interval. Okay. Well, this is the last question. So we want to find tan of -1 over √3. So this one I can use the cast rule. So tan is negative in 2 and 4. So I'm going to draw my triangle in quadrant 2 and quadrant 4. Tan is opposite over adjacent, so opposite is 1, adjacent is 3, √3. In quadrant 2, it would be the negative, the √3 that's negative. In quadrant 4, it would be the 1 that's negative. And now we have to find our related angle. So pi over 6 is always adjacent to √3. So that's my related angle. And then I could do my solution sets by starting at 0 and going to the terminal arm. So in quadrant 2, it will be pi minus the related angle, so 5 pi over 6. And then in quadrant 4, we are measuring from 2 pi. We're not quite at 2 pi. So in quadrant 4, we will do 2 pi minus the related angle, which would be 11 pi over 6. Okay, so remember, you're always measuring from the x-axis. So in quadrant 2, it will be pi minus the related angle. In quadrant 3, it will be pi plus the related angle. And in quadrant 4, it will be 2 pi minus the related angle. We never measure from pi over 2 or 3 pi over 2, okay, from the y-axis. So we always measure from the x-axis. Right? If you measure from the y-axis, you're measuring the wrong angle. So in quadrant 1, it'll just be the related angle, whatever it is. In quadrant 2, it'll be pi minus the related angle. In quadrant 3, it'll be pi plus the related angle. And in quadrant 4, it'll be 2 pi minus the related angle. Okay, so it's pretty easy to find. And then if you were going in the negative direction, you would just go the opposite way. Right, you would just go in the opposite direction. We'll look at some of those later. Okay, so that's finding ratios given, or finding angles given ratios, arcs.